Yes. Leave a reply if you can hear me speaking. Leave a reply. The chat box. Okay. Right. Okay. Uh, we'll start. Right. Okay. Uh, now, in that second paper, question number 31 to 40. Question number 31 to 40. So these 10 questions are discussed in previous paper. So therefore, I don't discuss 31 to 40. All the questions in 31 to 40 are discussed questions from target model paper 1. So therefore, I don't discuss these 10 questions. I will discuss remaining questions. Question number 41 to 50 past paper questions. Question number 1 to 30, they are model paper questions, right? So I quickly keep on explaining. Right. Question number 1. Now there are some mistakes in this paper as well. So question number 1. Consider an equation capital X equals hc over lambda. Simple H is Planck constant, c speed of the light, y means length. The SI unit of capital X is Planck constant unit is joules per second. Now, I think I put wrong for most of you, but I think the right answer for this question is fourth one, I think. So mistakenly I put wrong. However, we'll correct that later. Capital X means capital X equals HC over capital Y. Capital simple H means what? Planck constant. Unit of Planck constant is joules per second. Sorry, joules seconds. And unit of velocity is meters per second. Meters per second. MS minus 1. Capital Y is length. So its unit is meters. So then, if you want to find the unit of capital X, seconds per second cancel out. Simple M cancel out. Then units of capital X is joules. It's joules, right? So therefore, right answer is fourth one. Fourth one is the right answer. So then, so we'll quickly go to question number third one. A mixture of carbon dioxide and nitrogen is taken in a vessel at 1 atm pressure. Masses of carbon dioxide and nitrogen are 7 grams and 11 grams respectively. partial pressure exerted by nitrogen is. Now, in this question number 3, now there's a container, right? There's a container. Now, in this container, there are two gases. Now, one is carbon dioxide, other one is nitrogen, capital N2. Carbon dioxide, nitrogen, capital N2. The total pressure inside this container is 1 atm. Total pressure inside this container is 1 atm. Okay. Then they say that mass of carbon dioxide and nitrogen are 7 grams and 11 grams respectively. It should be changed actually. Mass of nitrogen and mass of carbon dioxide are 7 grams and 11 grams respectively. Mass of nitrogen gas in this container is 7 grams. Mass of carbon dioxide in this container is how much? 11 grams. Now you can easily find the molar mass of nitrogen, molar mass of carbon dioxide. What is the molar mass of nitrogen? Capital M, molar mass. Molar mass of nitrogen, we can say 14 into 2, 28 grams per mole. 28 grams per mole. If you find the molar mass of carbon dioxide, carbon's 12, oxygen 16 into 2, 32, 44 grams per mole. Grams per mole. So then we know that now what we want to find, total pressure inside the container is 1 atm. We want to find the partial pressure produced by nitrogen. If you want to find the partial pressure produced by the nitrogen, I say partial pressure produced by the nitrogen is P capital N2. So this is equals to number of moles in the container, number of nitrogen moles in the container over total number of moles in the container into total pressure, right? If you want to find the partial pressure of nitrogen, what you want to do is you want to consider number of moles of nitrogen gas over total number of moles in both nitrogen as well as carbon dioxide into total pressure B capital T, right? That means simple in nitrogen over simple in total. That means nitrogen moles as well as oxygen moles into total pressure BT. Hands up and everything is clear. Up and everything is clear. Hands up. Up and everything is clear. Okay. Then how do I find number of nitrogen moles in the container? I know mass of nitrogen is 7 grams. I know molar mass of nitrogen is 28 grams per mole. How do I find number of nitrogen moles? If I want to find the number of nitrogen moles, simple in nitrogen, I know mass because we know that. You know an equation, number of moles equals mass over molar mass. If you want to find number of moles, that is equal to mass of the gas sample over molar mass of the gas sample. Then what is the mass of nitrogen? 7 grams. What is the molar mass of nitrogen? We found 28 grams per mole. 28 grams per mole. Then grams to grams cancel out. 7 over 28 means what? 1 over 4. 1 over 4, 0.25 moles. We found number of nitrogen moles in this container is 0.25 moles. Likewise, we can find number of carbon dioxide moles as well. How do we find number of carbon dioxide moles? Same idea. If you want to find the number of carbon dioxide moles, mass of carbon dioxide over molar mass of carbon dioxide. Mass of carbon dioxide is how much? 11 grams. Molar mass of carbon dioxide, we know 44 grams per mole. 44 grams per mole. So when you simplify this, you will end up with 1 over 4, again 0.25 moles. Then what is the total number of gas moles present in this container. 0.25 carbon moles, 0.25 nitrogen moles. Altogether, the total number of moles present in the container is 0.5. Number of nitrogen moles, how much? 0.25. Total number of moles, 0.5. Total pressure in the container is 1. So therefore, we can say partial pressure produced by nitrogen gas is how much? 1/2 means 0.5. Hands up who understand this question. I understood. Hands up. Question number 3 is done. Right. Question number 6. Question number 6. Normal human eye can focus from 25 centimeters to infinity. The diameter of the eyeball is 2 centimeters. Diameter of the eyeball changes to 2.2 centimeter due to the eye pressure. Due to the eye pressure, diameter of the eyeball changes from 2 centimeter to 2.2 centimeters. Then they are asking, but other parameters don't change due to this effect. They are giving some options. Now look at it. Now this case. Now we know that now question number 6. Right. And now they have given vision, range of vision of this eye is what? 25 centimeters to infinity. 25 centimeters to infinity. Right? 25 centimeters to infinity. So he can see, this person can see any objects in between 25 centimeters to infinity. Right? Infinity. So this is 25 centimeters. 25 centimeters to infinity. If you keep the object in between 25 centimeters to infinity, any point in between, this I can see that object. So now they have given diameter of this eyeball is how much? 2 centimeters. Diameter of this eyeball is how much? 2 centimeters. Now what happens now? Initially diameter of this eyeball is 2 centimeters. His range of vision is 25 centimeters to infinity. That means we can say that even you keep the object at the infinity, what will happen? Light rays are focused exactly on the retina. Even object is at the infinity, these light rays focus on retina. We know that when the object is in the infinity, we know light rays are parallel to principal axis. If your object is at the infinity, we know light rays are parallel to principal axis. Then parallel light rays coming toward the eye. Parallel light rays coming toward the eye. Now object is at the infinity, then light rays are parallel to principal axis. After these light rays incident on this lens, convex lens, what will happen? If this eye can see this object at the infinity means, after converging, definitely these light rays must converge to the retina. Light rays must converge to the retina. Right? So that's why, suppose if your diameter of your eyeball is 2 centimeters, when the object is in between 25 centimeters to infinity, even object is at the infinity, this person can see the object, because when object is at the infinity, these light rays are exactly converging at the retina when the diameter is 2 centimeters. Now what happens? Diameter of the eyeball is increasing. Diameter of the eyeball is increasing. When the diameter of the eyeball is increasing, now diameter is 2.2 centimeters. Then what will happen? If your diameter is now 2.2 centimeters, then what will happen? Now diameter is 2.2 centimeters, but now the problem is what? When the diameter is 2.2 centimeters, previously even object is at the infinity, the light rays were exactly converging to retina. Therefore, object placed at the infinity, this I can see. But now the problem is, now diameter is 2.2 centimeters. Now here is your retina now. Now here is your retina, but you can see when you keep the object at the infinity, light rays are converging just before retina. Just before retina. So then what happens? This eye cannot see objects placed at far. Do you understand? Hands up who understood. Because of the increase in diameter of the eyeball, these light rays are converging just before the retina. This person cannot see objects at infinity. Hands up who understood I explain right now? Okay. Then what's the problem? The problem is what? This eye cannot see objects at very far. That means what type of lens that we want to use? We want to use concave lens. Because I don't explain why we want to use concave lens. I think this is taught in theory. If a person cannot see object kept at very far, we are using concave lens, and we know that concave lens is the focal length of concave lens equals to what? Huh? The far point of that eye. So we learn these things. So then, you know the answer, right? Concave, you want to use concave lens. He can't see objects at distance. That's the idea. Hands up, who understood I'm explaining? Understood? Okay, right. Question number 6, then answer is, I think, it's fourth one. Right. Now question number 8 one. Give compound microscope. Given compound microscope is in normal adjustment as shown in the diagram. Find its magnifying power. I will give 2 minutes. I will give 2 minutes. Just give the answers. If you can remember, you can easily tell the answer quickly. I will give 2 minutes. Tell me the answer. Now, what you can remember regarding microscopes on a normal adjustment? Microscopes, compound microscope having two what? Convex lenses. Compound microscopes have two convex lenses. If your compound microscope is on a normal adjustment, that means final image produced by the microscope is at the near point. That's the idea. Now they have given a compound microscope. Question number 8 one. 8 one. Now there's a compound microscope. Okay. Then this is your what? Objective lens. This is eyepiece lens. Now that's an object. They have given object height as 1 centimeters. Object height is given as 1 centimeters. 1 centimeters. right? So then this objective lens, objective eyepiece. So this objective lens take this as the object, produces an image somewhere here, right? Usually we keep this object in between focal length of objective lens and center of curvature of objective lens. We keep this object in between f0 and 2f0. And then what will happen? Image produced by this objective lens will be somewhere here, inward image, larger inward image. This is the image, right? Object height is 1 centimeter. If you need this height, I see this height as image height, simple H. When you consider objective lens, this is the object. Image is, this is what is the image, I1. Then what happens? This eyepiece lens thinks this as the object. Eyepiece lens considers this as the object and eyepiece lens forms an image. That is the final image somewhere here. Virtual image. And in this question, they have given height of the object as 1 centimeters and they have given height of final image. This one, I2. Height of final image as 9 centimeters. 9 centimeters. This is 9 centimeters. What they are asking us to find the angular magnification. They are asking us to find the angular magnification. Then what is angular magnification? Capital M means alpha dash over alpha. What is alpha dash? What is alpha? Alpha dash means what? Angle subtended by final image. Angle subtended by final image. Angle subtended by final image. This is your alpha dash. Right? What is alpha? When you keep this object at least distance of distinction in front of your eye, that angle subtended to the eye is alpha. That means alpha means what? Suppose if you keep this object exactly at the near point, if not least distance of distinction of this eye, angle subtended by the object to the eye we are calling as alpha. If this is your naked eye, this is your eye, when you keep this object exactly at the near point of this eye, if it is a healthy eye, what is the near point? Near point is 25 centimeters from eye. Then angle subtended by this object on the eye we are calling as what? This is alpha. This is alpha. Then what is alpha dash? So by using compound microscope, the final image, this is the final image, angle subtended by final image at the lens is what we are calling as alpha dash. As this compound lens is under normal adjustment, what can we say about the distance from here to here? Final image forms at the least distance of distinction. So this length is also, you can say 25 centimeters. Because we know that under compound microscope normal adjustment, final image forms exactly at the near point. That means least distance of distinction. So therefore you can say that this final image is 25 distance from this eyepiece. 25 centimeters. Now then when we were deriving this alpha dash of alpha, we assume that as your alpha dash and alpha both angles are very small, we can take their tan values, tan alpha dash over tan alpha. Then what is your tan alpha dash? Tan alpha dash, if I consider this large triangle, tan alpha dash means what? Opposite 9 centimeters, adjacent 25 centimeters. So I can say tan alpha dash as 9 over 25. Tan alpha, opposite is they have given height of the object is 1 centimeters. Opposite over adjacent, 25 centimeters. 1 over 25 centimeters. 25 cancel out. Then answer will be 9. So angular magnification of this compound microscope on a normal adjustment is what? 25, what, 9. Hands up who understood or explained? Understood? And that is also discussed. Then we discussed question number 1, then we discussed 3, then 6, then 8. Right. Ninth one. An ice cube of 1 kilogram is at 0 degrees Celsius. An immersion heater of 200 watts is immersed into the ice cube. It absorbs 20% of the heat energy which is required to melt from the surrounding. The latent heat of vaporization is how much? 3 into 10 to the power 5 joules per kilogram. What is it taken to melt completely after the heater switch is switched on? No, that's an ice cube. Question number 9th one. That's an ice cube. This is your ice cube. Right. Now they have given mass of this ice cube is how much? 1 kilograms. Mass of the ice cube is 1 kilograms. Now what we do by using some sort of immersion heater, we heat this ice cube. Right? By using an immersion heater, we heat, if not we provide heat energy to this ice cube. Let's say this is my immersion heater. Some sort of heater. This heater provides heat energy to this ice cube. Now they have given power of this immersion heater is how much? 200 watts. That means what? Power of immersion heater means what? Amount of heat energy produced by this immersion heater per unit time per second is 200 joules. That means every 1 second, this immersion heater produces 200 joules of heat energy. That's the idea of power of immersion heater. Every 1 second, 200 joules of heat energy is produced by this immersion heater. The power of this immersion heater is how much? 200 watts. The thing is, this ice cube absorbs only 20% of that heat. Even your immersion heater produces 200 watts of heat energy. If not heat power, ice cube absorbs only 20% of that heat. Then what is the amount of heat absorbed by the ice cube every 1 second? Every 1 second, 200 joules of heat energy is produced by the immersion heater. But every 1 second, your ice cube absorbs only 20% of heat energy. Then if you want to find the energy absorbed by the ice cube every 1 second, what you want to do? You want to obtain 20% of that. Then they are asking how long this ice cube takes to completely melt. Then we know that now currently what happens? There is a change in phase. That means what? Solid becoming liquid. So therefore we are using Q equals ml equation. As power is involved, what we do? We divide both sides by simple T. Because power. Then we know that Q over T means what? The power, heat power absorbed by the ice cube. That means every 1 second, amount of heat absorbed by the ice cube. How much? Every 1 second, this ice cube absorbs 200 into 20 over 100. This amount of joules. So therefore, QOT means how much? 220%. Mass of the ice cube is 1 kilograms. Capital L. Latent heat of vaporization, they have given how much? It should be fusion, actually. 3 into the power 5. The time is simple t. So then what we can say 100, these two get cancelled out. Then 20 into 2 means 40. 3 10 to the power 5 over simple t. If you subject simple t equals what? 3 over 40 10 to the power 5. When you further simplify it, simple t equals how much? Uh, I can say that 300 10 to the power 3 over 40, 0 cancel out. 30 over 4 means 7.5. 7.5 10 to the power 3 seconds. This is the answer. Hands up who understood this question. Understood. Right. Then question number 10. An object of mass simple limb having a linear momentum capital P comes to rest by traveling simple x distance on a rough horizontal table. The coefficient of friction between the object and the table is. Now 10th one. Now, object of mass simple limb having a linear momentum capital P comes to rest by traveling simple x distance on a rough horizontal table. Let's say this is your table. Now that's an object. Let's say initially linear momentum of this object is capital P. Linear momentum is capital P. Now what is linear momentum? Linear momentum means mass into velocity. That means initially this object is traveling to the right side direction. Because if this object is having a linear momentum, means this object has a velocity at this instant. Mass of this object is simple m. So initially what happens, this object is traveling to the right side direction. As this object is traveling to the right side direction, what happens due to the frictional forces? Due to the frictional forces acting on this object, what happens? Velocity of this object gradually decreases. Finally, object becomes rest. Right? Then you know that what is the equations we learned for kinetic energy? Kinetic energy means half mv squared. Half mv squared. If not, can you remember we wrote another two equations for kinetic energy in terms of momentum and velocity of the object, and also we obtained an expression for kinetic energy in terms of mass and momentum. The very popular equation is kinetic energy equals half mv squared. So there is two more equations for kinetic energy. Kinetic energy equals what? P squared over 2m. Here capital P means momentum. This is another equation. Then you learn that another equation for kinetic energy in terms of momentum and velocity. Kinetic energy equals half PV. Half PV. Hands up, how many of you can remember these three equations? I think everyone must remember this equation. How many of you can remember these two equations, remaining two? Right? So how many of you can derive these equations? Please hands up, how many of you can derive from this kinetic energy equation by using P equals mv? By using these two equations, how many of you can derive these two? Hands up. Okay, so then I don't explain. Then basically what happened? Initially, this object was having a kinetic energy. Finally, that kinetic energy is zero. Basically, what happened to kinetic energy? Let's say initially this object was having 500 joules of kinetic energy. Finally, the kinetic energy of the object is 0. Then what happened to what happened to that 500 joules of kinetic energy? That 500 joules of kinetic energy converted to work done against friction. Let's say the distance traveled by this object as simple x, this gap is simple x. And then we can say change in kinetic energy equals, if you apply conservation of energy. Now initially this object was having some sort of kinetic energy. Finally, its kinetic energy is 0. What happened to kinetic energy? That entire kinetic energy is converted to do a work done against friction. So change in kinetic energy equals what? Work done against friction. Against friction. Now what is the equation for work done? Work done means what? Force into displacement. Capital F into capital S. Force into displacement. Change in kinetic energy. What is the kinetic energy at the beginning? In terms of P and simple limb? In terms of P and simple limb, what is the initial kinetic energy? P squared over 2m. P squared over 2m. Final kinetic energy is 0 because velocity is 0. Kinetic energy is 0. This is equals to what? Work done against friction. Work done means what? Force into displacement. Now this time who is your force? Frictional force. Capital F into simple x. Now what we want to find actually? We want to find the coefficient of friction between object and the table. Now here capital F means friction force. We know frictional force that is equals to what? Mu into capital R. Mu means coefficient of friction between the surfaces. Capital R means normal reaction force. Now in this case, your normal reaction force equals to weight, simple mg. If you consider this as your object, if you mark the vertical forces, weight is acting downward direction, normal reaction force is acting vertically upwards, then you can say what? Capital R equals simple mg. So therefore mu R equals simple mg. Then you can say friction force acting on this object throughout the motion is what? Mu mg. So if you simplify P squared over 2 simple m, frictional force is what? Mu mg. Frictional force mu, you want to find mu, this coefficient mg into simple x. So when you subject mu actually, you subject mu, so you can say that mu equals P squared over 2 simple m squared gx. Hands up, genuinely understood this part? Understood? Right. So then we'll discuss 2 more questions, and when time is 8 p.m., we'll take a small break. Right. Then 10th one. 15. Question number 15. Several incident angles, simple I, and corresponding deviated angles, simple D, are obtained for the light ray which goes through a prism, and a graph is drawn as shown in the diagram. The possible values for the angle theta is. Now look at it. So this is also very important. At this time. Now they have given angle of deviation, variation of angle of deviation with incident angle in a prism. Question number 15. Angle of deviation, simple D. Incident angle, that means I. This is the graph. And you must know theory parts as well. Okay. Now they have given when angle of deviation is 50. If you can remember, there are two possible values which can give same angle of deviation. So in a prism, for two different incident angles, your total angle of deviation will be same. That means you will obtain same angle of deviation for two different incident angles. Now, for an example, in this case, you will obtain total angle of deviation as 50 degrees for two possible incident angles. One is they have given as 30 degrees, other one is theta. So in this question, we want to find theta, but you want to understand normally for any angle of deviation, you can obtain any angle of deviation with two different incident angles. That's the main idea, except one important point. Exactly the minimum deviation, exactly the minimum deviation, there is only one possible incident angle. The summary is a very important point. In order to obtain an angle of deviation, there are two possible incident angles. You can obtain same angle of deviation. There are two possible incident angles. You can obtain same angle of deviation except one point. Exactly minimum deviation, there is only one value for incident angle. Hands up who really understand this one. Now this angle is they have given 45 degrees. Now basically we want to find is theta. Now can you remember uh, we derived some important things regarding prisms. Capital A plus simple D equals what? I1 plus I2. This is one important equation we discuss in prism part. Then we discussed capital A equals R1 plus R2, right? Suppose if it is the minimum deviation scenario, now you know that if it is minimum deviation scenario, this equation will be simplified as A plus capital D equals 2I. A plus capital D equals 2I for the minimum deviation scenario. For this point, for this scenario, this is capital D. And then we know that, now they have given minimum deviation also 40 degrees. This is 40 degrees. For the minimum deviation scenario, this equation will be simplified as what? Capital A equals 2 simple r. 2 simple r. I think all of you can remember. Then what's our goal? Actually, I want to find theta. That means when my angle of deviation is 50, I want to find I2 value. When my angle of deviation, simple D, when my simple D is 50, I know I1 value is how much? 30. Actually, I want to find I2 value. But the problem is, I know simple D, angle of deviation is 50. One of the incident angle, I know it has 30. I want to find the other incident angle, but the problem is I don't know prism angle. Now here capital A means what? Prism angle. Capital A means prism angle. So what I do, initially I will find prism angle. How do I find prism angle? They have given enough data for minimum deviation. Minimum deviation is 40. In that case, your simple I is 45. Capital D. Minimum deviation is 40 degrees. Simple I is how much? 45. Then you can easily find capital A if you use this equation. capital A plus minimum deviation is 40 degrees, that is equals to what? Two simple line. You obtain minimum deviation when your incident angle is how much? 45. 2 into 45, 90 minus 40, 90 minus 40. That means 50 degrees as your minimum deviation. Sorry, 50 degree as your prism angle. When your prism angle is 50, now you can consider this equation. Prism angle is 50. Angle of deviation is also 50. I1, one of the incident angle is 30. Other possible incident angle is what? Theta. So then when you simplify this, you will obtain 100, 30 means 70. Theta equals 70. Your answer is theta equals 70. Hands up who understood what I explained up to now. Hands up. Okay, now time is exactly now. Now time is what? 7:56. Uh yes, we'll take a break and we'll come. We'll take a 10-minute break and we'll come. Time is 7:56. Come exactly at 8:05. Come exactly at 8:05. Right. Okay. Now, quickly discuss question number 29. The figure shows velocity time graph of an object. Displacement time graph of the object is best represented by. Now, look at it. Now, your velocity time graph is something like this. Your VT graph. Question number 29. Now, they have given VT graph like this. Velocity time graph. Now, this is your VT graph. Now, they are asking the corresponding displacement time graph. How do we do the corresponding ST graph? ST graph. Now we know that in ST graph, gradient represents velocity. gradient. Simple name gradient. If not, we call it tan theta. In ST graph, gradient. If not, tan theta represents velocity. In VT graph, velocity time graph, where y-axis represents velocity. Now we have a velocity time graph. Then we want to obtain corresponding displacement time graph. Now, what's happening now? I can divide this graph into two sections. This is my section 1, section 2. Section 1, section 2. Now, if you consider this section 1, if not this part 1, what's happening to your velocity? During this section, your velocity is negative. Negative velocity, negative phi. That means if you consider velocity to the right side direction as positive, when object is moving to the right side direction, that object's velocity is positive values, plus 5 ms minus 1, plus 6 ms minus 1. When the object is moving to the right side direction, its velocity is positive. Suppose if the object is moving to the left side direction, opposite direction, we say that velocity is negative. Negative 5 ms minus 1, negative 100 ms minus 1. Now you can see the first part of this graph, velocity is negative values. Below this x-axis. So negative values, what will happen with the time? What will happen for your negative velocity? Negative velocity is decreasing, right? Negative velocity decreasing. So when you consider your second part of this graph, you can clearly see that all the velocities are positive values. That means positive velocity. That means currently this object is moving to the right side direction. Second part, positive velocity is increasing gradually with the time. Second part, positive velocity increasing. Now we know that in ST graph, if you want to represent velocity, velocity means in ST graph gradient. Negative velocity decreases means in ST graph, negative gradient must be decreased. Positive velocity increases in VT graph means in ST graph, positive gradient must be increased. Right? Now gradient, negative gradient means, understand negative means, suppose if your gradient is negative means that angle is obtuse. Suppose if your gradient is positive means that angle is acute. In this section, obtuse angle, negative gradient means obtuse angle. When negative gradient decreases means your obtuse angle must be increasing. Your obtuse angle must be increasing. See, your obtuse angle keep on increasing. Then here, positive gradient increases means what? Acute angle increases. Acute angle increases. Your acute angle is keep on increasing. Is the idea. The next one, question number, we'll discuss 30. An object of uniform density floats partially submerged so that 20% of the object is above the water. 3 Newton force presses down the top of the object so that the object becomes fully immersed. Volume of the object is, consider the density of water is 1000 kilograms per meter cube. Now question number 30. Question number 30. Now initially there's an object. That object is immersed in the water partially. The object. The object. So let's say the total volume of this object is capital V. If you say total volume of this object is capital V, total volume is capital V, right? Then they say an object of uniform density floats partially submerged so that 20% of the object is above the water. If the total volume is capital V, what is the volume above the water surface? 20%. That means 0.2 V. So this volume is 0.2 V. Volume above the water is how much? 0.2 V. Then what is the volume below the, what is the volume submerged in the water? Volume above the water is 0.2 V. If you want total volume is capital V. If you want to find the submerged volume, V minus 0.2 V, that means 0.8 V. This is 0.8 V. Submerged volume is 0.8 V. 0.8 capital V. Now we know that initially this object has submerged and this object is in equilibrium. When this object is submerged partially, what are the forces acting on this object? There are two forces. Weight force is acting downward direction and the upthrust force acting on this object upward direction. So weight is acting downward direction. Mg. Upthrust force acting on this object capital U upward direction. And definitely we know that suppose this object is under equilibrium, Mg equals U. Upthrust force must be equals to Mg. Right? Okay. Then upthrust. What is upthrust? Upthrust means what? We know, we learned upthrust means V rho G. Upthrust force produced by this liquid, in this case this water, on this object is what? V rho G. Now what is this capital V? Capital V means what? Submerged volume of the object. Even the total volume of your object is capital V, what is the submerged volume of this object in the water? 0.8 V. Rho means what? Density of this liquid, not the object. Here rho means density of the liquid. Submerged liquid is liquid. Density of this liquid is how much? They have given 1000. G means gravitational acceleration. So U means what? V rho G. Now V means what? 0.8 V. 0.8 V. Density of this water, this liquid is how much? 1000. Gravitational acceleration is simple G. That is equal to what? Mass of this object is simple m. G is acceleration. Now mass means we know mass over volume is density, right? Then mass means volume into density. Mass of this object means what? Mass of this object is equals to volume of the object. What is the total volume of your object? Total volume of your object is capital V into density of the object. I say density of your object is rho G. G cancel out. Here VV cancel out. Then you can easily find density of the object. So your density of the object is how much? 800 kilograms per meter cube. Now what we do actually, by providing 3 Newton force on the top surface of the object, we immerse this object completely into this water. By providing some sort of 3 Newton force on the top surface of the object, what we do, we immerse this object entirely into the water. If you completely immerse this object. Now this object is completely immersed in this water. Then how many forces acting on this object? The force you applied on the surface of the object in downward direction, 3 Newton. And also weight of this object, simple mg, as usual mg. And then upthrust force. Now you know that comparing with previous upthrust force and now upthrust force are different. Why? Submerged volume of the object is different. Previously submerged volume is 0.8 V. Now submerged volume is total volume of your object. That means capital V. When your submerged volume changes, upthrust force also changes. I say now upthrust force as U1. Now we can say there are 3 forces acting on this object. Downward direction 3 Newton. Weight is also downward direction. Up thrust force acting upward direction. Then we can say this object is under equilibrium. Then we can say downward forces equals to upward forces. Then we can say what? 3 plus mg equals up thrust force U1, right? Now 3 simply means what? Mass of the object. We know mass can be written as what? Volume of the object into density of the object. I say volume of the object is my capital V. Density of this object is how much? We found 800 actually. G means 10. Gravitational acceleration is 10. Up thrust force. Now up thrust means V rho G. V means submerged volume. Now what is the submerged volume of the object? Entire object is submerged. Therefore, submerged volume means capital V. If you want to find up thrust U1, we consider it as capital V. Rho means density of the liquid. How much? 1000. Gravitational acceleration is 10. So when you simplify this, you will obtain 3 equals. If you bring this one that side, somehow you will obtain how much? It's 1000. You will obtain V into 200 into 10. When you subject capital V, you will obtain 3 over 200 into 10. Right? That means what? You will obtain 1.5 10 to the power minus 3 meter cube as your volume. If you convert meter cubes into centimeter cube, what you want to do? Suppose if you have volume in meter cubes, and if you want to convert that meter cube volume into centimeter cubes, what you want to do? You want to multiply by 10 to the power 6. And then if I want to convert meter cubes into centimeter cubes, I want to multiply by 10 to the power 6. And then I will obtain 10 to the power minus 3. I want to multiply by 10 to the power 6. 10 to the power 6. Then I will obtain my answer in centimeter cubes. How much? 1500 centimeter cubes. Hands up, understood? Hands understood? Understood. Then we discussed 30 discussed, 29 discussed, 28. Then we'll discuss 27, then 26. 28. 28. So now keep on focus. That's what I can say now. So we'll do as soon as possible. Sometimes we might do a paper. We might write a paper on tomorrow night mostly. Sometimes tomorrow morning, I will do a session like discussing the remaining parts in this paper. We'll see. Hands up who really understood this question. Understood hands? Understood, genuinely understood. Hands up. So you want to keep on practice these type of questions. So even one can alter this question in different formats and they can give. So therefore, you must know how to manage whatever the knowledge that you gain and how to manage according to the given question, how to manage your skills and your knowledge. So that's what important. In your exam, they won't give a question very similar to this. So that's your knowledge and it's your skill actually. Okay. Next one. A block 28th one. A block takes twice. Someone please count what are the questions that we discussed and how many questions we discussed so far. Someone please take a small count. Okay. I will ask. A block takes twice as much time to slide down a rough 45-degree inclined plane as it takes to slide down an identical smooth 45-degree inclined plane. Coefficient of kinetic friction between the block and the rough inclined plane is. Look at it. Question number 28. Now here, inclination of this plane to the horizontal is how much? 45 degrees. One plane is rough, other plane is very smooth. If it is a rough plane, there is friction forces acting on the object. If the plane is smooth, there is no friction forces. That's the difference. Now there's an object. Let's say initially both the objects have initial velocity 0, 0 initial velocity. No matter it's rough or smooth, initial velocity is 0. This is smooth. Right? If I draw a general position of this object, we can mark the forces actually. What are the forces acting on this object when this object is moving on a rough plane? Definitely weight force is acting vertical downward direction, weight, mg, and this object is in contact with the plane. There is normal reaction force acting on the object perpendicular to the plane. There is normal reaction force, capital R, perpendicular to the plane. This angle is obviously 45 degrees. Then weight force acting on the object, normal reaction force is acting on the object. As this object is moving downward direction, there is frictional forces acting along the plane upwards. Your friction force, capital FF, right? Then let's say this object finally, the displacement traveled by this object is, let's say, capital S, capital S. When you consider this object is also, if you draw a general position of this object, here there are two forces. One is weight force acting downward direction. Other one is what? Normal reaction force acting on the object, capital R. There is no frictional forces. In this case, there are two forces. But in this case, there are three forces on the object. Friction force is the additional one. This angle is same as 45. Right, okay. Now let's say acceleration of this object is simple A1. Acceleration of this object is, let's say, simple A2. Because initial velocity is 0. When you release the object, what will happen? Velocity is increasing, both the cases. Velocity increases means both the cases, object is accelerating. I say acceleration as simple A2. So this object also travels same displacement, capital S. Same displacement, capital S. Capital S. Now they have given in the question, block takes twice as much time to slide down in a rough plane comparing with smooth plane. If you say time taken for this object to move in a smooth plane is simple t, in order to obtain simplest displacement, let's say this object has taken simple t time. Then in order to obtain the same displacement as this object on the rough plane takes twice the time. This time is 2 simple t. Then hereafter, what you want to do actually now, in order to find the acceleration, what you do, you apply F equals me. Then you want to apply linear motion equations. That's the idea. What you want to do is, after drawing some sort of diagram like this, you need to apply F equals me to find the accelerations. Then you want to apply linear motion equations. Then you can get the answer. If I want to find A1, what can I do? I can apply F equals ma in the direction of the motion. This object is moving along the plane downward direction. So I apply F equals ma along the plane downward direction. If I apply F equals ma, we want to split force components along the plane. Capital R is perpendicular to the plane, no contribution to the F equals ma equation, but mg cos 45, mg sin 45. mg sin 45 is acting along the plane downward direction, mg sin 45 minus friction force ff. Mass of this object is, let's say, simple m. Acceleration is, let's say, a1. acceleration is A1. Now we can further write this friction force also in terms of mg mu. Coefficient of friction is, let's say, mu. We want to find capital mu. Friction force means what? Mu r. We know friction force is what? Mu r. R means normal reaction force. Now this time we know normal reaction force equals to what? Mg cos 45. You know why? Mg cos 45. So therefore you can write Mg sin 45 minus friction force is Mg cos 45. Mu Mg cos 45. Mu Mg cos 45 equals MA1. MA1. Now you can cut all the simple limb terms. All the simple limb terms you can cut down. Then you can say what? Cos 45 means what? 1 over root 2. Sin 45 also 1 over root 2. So you can take that 1 over root 2 outside. G 1 over root 2 if you take outside. Then it will remain 1 minus mu A1. Hands up who understood how I obtained simple A1, hands up. Hands up who understood how I obtained simple A1. Now likewise, very similar manner we are applying F equals MA4. This one has been. Same manner along the plane downward direction. We apply F equals MA. Now this time, there is only one force along the plane, mg sin 45. Simple limb, acceleration is what? A2. So you will get your A2 as what? Mm cancel out. You will get your A2 as what? G sin 45. That means G sin 45 means G over root 2. G over root 2. Your equation 2. After finding accelerations, you want to apply this linear motion equation. In your selected linear motion equation, it must include uy. Both the cases initial velocity is 0. And definitely your selected equation must include capital S as well. Capital S as well. Because we know that both the objects travel same displacement. Because they have given time ratio, time must be included. We obtain accelerations, acceleration must be included. The best equation is S equals ut plus half at squared. What we want to find? We want to find what? Mu. So if I apply S equals ut plus half at squared for this one, in this direction, if you apply S equals ut plus half at squared, displacement is S, initial velocity is 0. This entire ut term becomes 0. Half acceleration I found g over root 2 1 minus mu. Time is 2 simple t. Time is 2 simple t whole squared. So this must be equal. If I find the if I apply S equals to t for this one, S equals to t plus half at squared for this one, S equals u is again 0, half acceleration is g over root 2. Now time is simple t squared. If I divide these two equations, problem solved. You can divide it. If not, you can equal it as well. It's up to you. If I divide it, you can divide it. If not, you can equal it. If I divide this side, S over S means 1. Half of cancel out, g over root 2 cancel out. T squared cancelled. Here 4 is remaining. So 1 minus mu into 4 is remaining. That's it. And then when you expand this bracket, 4 minus actually 4 mu. However, 4 mu means 3 mu means 0.475. Hands up. Really, you understood this question? Hands up. Understood. Generally understood. Now practice these questions many times. These are very good questions. 27th one. 27. So we'll stop at 9 again. So we'll stop at 9. 9. So we'll start back again 9:30 to 10:30, maximum 11. Sometimes I might stop at 9 and I won't do the session as well. It depends on my mood. 27. How many questions we discussed so far? Someone leave a reply. Put in the chat box how many questions we discussed so far. Someone? Only 10. Right, okay. So look at question number 27. A wind turbine has blades that sweep an area of 200 meter cube. It converts the power available in wind to electrical power with an efficiency of 50%. What is the electrical power generated if the wind speed is 10 ms minus 1? They have given density of air is how much? 1.3. Density of air is 1.3. This is also a very good question. Now, basically, wind carries kinetic energy because when these air particles are moving, wind is blowing means basically what happens? These air particles are moving. As these air particles are moving, air particles have some sort of kinetic energy. So, what is the energy stored in wind? Basically, kinetic energy of air particles. So, what happens when these air particles collide on the blades of a turbine or blades of something, wind turbine? That kinetic energy is somehow converted to electric energy. So first of all, try to find the kinetic energy on the wind. Then problem is simple. Question number 27. Let's say this is your wind turbine. Okay. This is your wind turbine. Right? As this wind turbine is rotating, as this wind turbine is keep on rotating, you want to understand. Now they have given what? They have given wind turbine has blades. These are the blades. Blades that sweep an area of 2000 meters squared. When these blades are rotating, so you can understand, let's consider a fan, how many blades your fan has. There are 3 blades actually. Some fans, there are 4 blades. If it is a stable fan, it also having 3 blades. Now you want to understand when these blades are rotating, basically these blades sweeps a circular cross section, right? Do you understand? When these blades are rotating, basically these blades forms some sort of circular cross section. So now what happens? This wind is blowing in this direction. Very carefully understand. This is very important. So wind is blowing towards the plates. That means all your air particles are moving towards the blade. We know that each air particle carries some sort of kinetic energy. As these air particles are moving, they have some sort of kinetic energy. So these air particles are moving towards the blade. These air particles carry some sort of energy. So now they have given velocity of each particle is capital V. Now they have given velocity of the wind as V. Now they have given what? Velocity. If the wind speed is 10 ms minus 1, that means velocity of the each air particle is 10 ms minus 1. So you want to understand within 1 second, very carefully understand within 1 second. Now they have given velocity of the wind is how much? Velocity of the wind is 10 ms minus 1. That means within 1 second, what is the distance traveled by the wind? Within 1 second, distance traveled by the wind is 10 meters. If you apply C equals UT, velocity of the wind is 10. Within 1 second, distance traveled by the wind is how much? 10 meters. Within 1 second, every 1 second, if I ask, every 1 second, wind is traveling 10 meter distance. And also what happens when this wind is blowing towards the blades, these blades cuts a circular cross section of the wind. Very carefully understand. When these blades are rotating, this blade cuts a circular cross section of the wind. So every 1 second, if I ask, every 1 second, what is the volume of the wind cut by the blades? If not, what is the volume of the wind passing through the blades? If you know the cross sectional area, if you know every 1 second distance traveled by the wind, if you know every 1 second distance traveled by the wind, if you know every 1 second distance traveled by the wind, ne? Capital V, capital V, ne? If you know every 1 second distance traveled by the wind, that is capital V, ne? If you know cross sectional area of the wind, sorry, if you know the cross sectional area cut by the turbine blades, that is capital A, that is capital A. If I ask every 1 second, what is the volume of the wind passing to the turbine? Leave a reply. Leave a reply. Everyone. If I ask you that now, this wind is blowing this direction. Yeah, wind is blowing this direction. If I ask every 1 second, what is the volume of the wind colliding with the blades? If not passing through the blades, what is the volume? Leave a reply. Everyone. Every 1 second, what is the volume passing through these wind blades? Others, no answers. Quickly, only few, only few. AV, because you can see that every 1 second cylindrical volume of capital A into V, cylindrical volume, cross section area is capital A, distance is V. Every 1 second cylindrical volume AV is passing to the blades. Do you understand? Every 1 second capital AV volume of the wind is passing to the blade every 1 second. Then now they have given density of this wind. What is the volume of the wind passing through every 1 second? AV. Volume of the wind passing through every 1 second is AV. If I ask density of the wind is rho, if I ask every 1 second, what is the mass of wind passing to the blades? If not, what is the mass of the wind colliding on the blades? How do you find that? Mass equals volume into density. Then volume means what? Area into velocity. Density is rho. Every 1 second, mass of the wind passing through, if not colliding on the blades, is AV rho. Then I want to know that basically what is the energy carried by this wind? Kinetic energy. If you know the mass of the wind as AV rho, what is the kinetic energy carried by this wind, this mass? Kinetic energy means half mv square. If you want to find the kinetic energy carried by this wind, kinetic energy is what? Half mass of the wind passing every 1 second is AV rho, and velocity, same velocity v square. Then you can obtain an expression for kinetic energy of the wind passing through every 1 second, passing through the blades is what? Half A rho V cube. Hands up, now everything is very clear. Now they have given cross section area is 2000. Cross section area 2000. Every 1 second, every 1 second. If you try to find the kinetic energy on the wind, every 1 second, half area is 2000. Density of the wind is, they have given 1.3. Velocity of the wind is how much? 10 cube, 10 to the power 3. Then when you simplify this, you will end up with how much? Here, 1300 kilowatts. Kinetic energy every 1 second. That means power. Energy per unit time is power. Every 1 second, kinetic energy on this wind is how much? This much. But we know only 50% of this kinetic energy is converted to electric energy, 50%. Now, what is the electric power produced? Every 1 second kinetic energy. Every 1 second, air particles collide on the blades with a kinetic energy of 1300 kilojoules, but only 50% is converted to electrical energy. Then every 1 second, what is the electric energy produced by the blades, produced by the turbine? 50%. 1300, 50%. That means how much? 650 kilowatts. Hands up who understood? Understood. So that is also discussed. Then we'll quickly go to question number 41, 42. 41, 42. 41, 42. Now 41, that is also a very easy question. If the distance between two masses is doubled, gravitational force between them will be decreased by the factor of. You can easily tell the answer is 4, but I will explain. Now this time, question number 41. Right? Now there are two masses. If the distance between two masses is doubled, let's say now there are two masses, I say m1, m2. Let's say initially gap between them is simple r. If the gap between them is doubled, that means now distance between these two masses is how much? 2 simple r. Now gap is 2 simple r. 2 simple r. Right? Because we know that we learned in gravitational field, when there are masses, there are attraction forces, always attraction forces. Electric field, between charges, there can be attraction as well as repulsion forces. But we learned, especially in gravitational field, between masses, there is only attraction forces. Then we know that the simple M1 attracts simple M2 towards simple M1. This one produces attraction force capital F. Then this one attracts this one. So therefore, this one produces a force on simple M1, this direction, attraction forces. Now let's say now here the attraction force is what? F1, 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 F1. Then can you remember the gravitational force? This is gravitational force. We know universal what? Gravitational. We know that Newton's law of gravitation. Capital F means what? G capital M simple M over R squared. Newton's law of gravitation. So when you consider gravitational force between two masses, that is directly proportional to multiplication of these two masses, simple M1, simple M2. Inversely proportional to distance squared. This is the proportionality constant we call universal gravitational constant. If you apply this equation for first case, F means what? G, mass is M1, M2, gap is R squared, equation 1. If you apply this equation for second case, F1 equals G, mass is simple M1, M2, gap is what? 2R whole squared. That means 4R squared. So when you divide 2 by 1, if you divide 2 by 1, you'll get what? F1 over capital F equals, F1 over capital F equals somehow 4. Somehow 1 over 4. That means when you increase the gap, the gravitational force will be decreased by the factor of 4. Hands up who understood this one? Understood? Then 42. Minimum velocity capital V that a particle should have in order to escape. Now all of you learned in gravitational field the escape velocities. How many of you can remember escape velocity? Hands up. How many of you can remember escape velocity? Hands up. How many of you can remember escape velocity? Hands up. Hands up. How many of you remember? Okay. Escape velocity 42. minimum velocity capital V that a particle should have in order to escape from the planet of mass capital M, radius capital R is given by. Now let's say this is our planet. This is my planet. Let's say radius of this planet is capital R. Now there's an object. This object is exactly on the surface of the planet. This object is on the surface of the planet. Let's say mass of this object is simple M. Now what I want to do is, actually I want to throw this object, but this object should never come to the planet again. I want to throw this one, but this one should never come back to the planet again. In order to throw this object, not coming back to the planet, means the velocity you want to provide is we are calling as escape velocity, right? So let's say escape velocity of this object is VE. Escape velocity of this object is VE. The velocity you want to provide for this object, not returning this object back to the planet. That means this object should go to the infinity. If this object never returns to the planet, means definitely this object should reach infinity. Then only this object never reaches the planet again. And we learned that at the infinity, potential energy, that means gravitational potential energy, also zero. When this object reaches infinity, suppose if you projected this object with an escape velocity, we know kinetic energy of the object also zero, right? Suppose if you projected this one with escape velocity, as this object reaches infinity, gravitational potential energy as well as kinetic energy of the object will become zero. When this object is on the surface of the planet, what is the kinetic energy? Half mass is simple m, velocity is escape velocity, VE whole square. When this object is on the surface of the planet, what is the gravitational potential energy? Minus G capital M simple M over R, minus G capital M simple M over R. But that means radius of the planet, capital R. Then what is the total mechanical energy on this object when this object is on the planet? Kinetic energy plus potential energy. When this object reaches infinity, its kinetic energy as well as potential energy becomes zero. Then what is the total energy of this object as it reaches infinity? Zero. According to conservation of energy, kinetic total energy of the object at here end, total energy of the object at here must be equal. Must be equal. Then we can write what? We can say half simple M V E squared equals G capital M simple M over capital R squared. Simple M cancel out. So if you subject escape velocity to G capital M over R, that means 2G capital M over R. Hands up who understood up to here. Now question number 43 is, you can directly say, okay, everyone leave a reply. Question number 43, what is the answer? 43, what is the answer? Everyone put the answers in the chat box, everyone quickly. Quickly. Put the answers. Put the answers. Put the answers. Answer is third one. Electric flux. Which of the following statements made about electric field lines? Sorry. Yeah, electric field line is false. Electric field lines can be either straight or curved. It's correct because it can be straight or curved. There is no issue. Electric field lines can be parallel to one another. That is also possible. Suppose if there is a uniform electric field, we know that electric field lines are parallel. Next one is electric field lines can form closed loops. That's wrong actually. Electric field lines cannot form closed loops. Do you understand? Fourth one, electric field lines begin on positive charges and end on negative charges. Actually, that is also false. Do you understand? There are two false actually, third one and fourth one. So if you consider third one is false also, that's fine. Fifth one, electric field lines can never intersect with one another. That's also correct. So no need to explain that one. All of you can understand that one. 44. Okay, we'll quickly discuss 46. 46, quickly discuss 46. Which of the following statement regarding electric field, if not potential, is true? Leave a reply. Leave a reply. That's also not difficult. That's also easy actually. Everyone leave a reply. Put the answers in your chat box. Everyone, put the answers in the chat box. Everyone put a reply. Now you want to understand now. The right answer is actually the right answer is if okay, let's check first one. If the electric field intensity is 0 at a particular point, then the electric potential must also be 0 that point. Can you remember when I was discussing these parts? We wrote these points by using red color pen. These are important points. At a particular point, electric field intensity becomes 0. That does not necessarily require to become electric potential also 0. That's false actually. Second one, if electric potential is 0 at a point, then the electric field intensity must also be 0 at that point. That's also false actually. In a particular point, if you are electric potential becomes 0. Particular point, I'm talking point. In a particular point, if you are potentially 0, that does not mean that it's compulsory to become electric field intensity also to be 0. That's wrong actually. But if the electric field intensity is 0 throughout a region, then the electric potential must also be 0 throughout that region. Hands up who says that one is correct. Hands up who says that is correct. Can you remember we were discussing conducting spheres? It can be solid or hollow. Can you remember we discussed conductive spheres? No matter the sphere is solid or hollow, we know that all the charges will be what lies on the surface of the sphere. Then can you remember under electrostatic conditions, electric field intensity inside the conductor at any point. Under electrostatic condition, electric field intensity inside the sphere at any point is 0. But still, even electric field intensity throughout this region is 0. If you consider electric potential, can you remember? In a conducting sphere, inside the sphere, electric potential remains constant. Even throughout this region, electric field intensity becomes 0, but still there is electric potential. So therefore, third one is also correct. Uh, no, third one is wrong. Fourth one, see, suppose in a region, throughout a region, if your potential is 0, definitely understand electric field intensity also must be 0. Don't confuse yourself. Very carefully understand. This is the idea. If you consider a particular entire region, in that particular entire region, if you realize your intensity is zero, then electric potential is not zero throughout the region. Throughout the region, electric potential is what? Constant. There is a value for electric potential actually, but it's opposite one. If you figure out in a particular region, if your electric potential is zero, then throughout that region, electric field intensity must be zero. Therefore, right answer is fourth one. Fifth one is also not right. Okay, these are points I discussed in the class. Then 46 also done. Uh, now look at 48 and 50. 48, 50, yes, 48, 50, then 49. Right on 9 o'clock. The atoms of an ideal gas have a certain mean kinetic energy at 10 degrees Celsius. Their mean kinetic energy will be twice at. Now we know that in gas laws we learned that if you consider mean kinetic energy is only directly proportional to temperature only. Do you understand? So E equals 3 over 2 kT, if not 3 over 2 nRT. I don't know how many of you can remember. Just go to the notes and refer them. Mean kinetic energy of an ideal gas is directly proportional to temperature. Okay, because can remember, we derived two expressions, mean kinetic energy for one molecule, and we derived mean kinetic energy for entire gas. 3 over 2 nRT, entire gas, 3 over 2 nkt, 3 over 2 nkt for one gas molecule mean kinetic energy. I don't know. However, you want to understand mean kinetic energy is directly proportional to temperature. But understand this is mean kinetic energy is directly proportional to temperature. But even I say something like that, that's false actually. We want to say mean kinetic energy is directly proportional to surface. Mean kinetic energy is directly proportional to what? Absolute temperature. That means temperature measured in kelvins. Absolute temperature. That means temperature measured in kelvins actually. So then you can say that in, let's say, when the temperature is how much? Temperature is 10 degrees Celsius. If you convert to kelvins, 273 plus 10, 283 kelvins. Let's say kinetic energy mean capital E. Now temperature is doubled. Previous temperature was how much? 10. And then they are asking, then mean kinetic energy will be twice at a temperature. Now if I, in case, if I increase the temperature, now kinetic energy is 2 capital E. Then I say temperature in Kelvin is Tk. So if I divide this proportionality, 1, 2, if I divide this proportionality 2 by 1, I can say 2E over capital E equals Tk over 283. Capital E cancel out. Then I will obtain the temperature at which kinetic energy is doubled. Tk is 2 into 283. That means how? That means what? 6, 16, 566 in kelvins. Am I correct? Yes. But if you want to convert 566 in Celsius, you want to subtract 273. You will obtain 3, 9, 293 kelvins. Sorry, 293 Celsius actually. That's the answer. Hands up, how many of you really understood? Understood. Hands up. Yes. Right. Okay. Now time is exactly 9 p.m. Now we started exactly at what 7 p.m. Now we have done 2 hours. So now I will leave a reply. Hands up who wants me to continue again from 9:30. Hands up. Okay, then we'll take a small break. We'll take a break, half an hour break. Then we'll discuss from 9:30 onwards. So tomorrow also we might do a discussion. However, okay. How many questions we discussed so far? How many? How many questions we discussed so far? How many? Leave a reply. So we discussed 17, but anyhow, we don't discuss 10 MCQs because I said that 10 MCQs are from previous model paper. So therefore, then roughly we discussed 27 MCQs. So we have 23 more MCQs to discuss. Today might we will discuss. Tomorrow also we have time. Sometimes tomorrow we will write another paper as well. So I don't know. Okay, anyhow, join at 9:30, sometimes 9:45. Okay, you can leave.